Hi, my name is Jake Sebring. I'm going to talk a little bit about the public lecture that I went to this past Monday on the 30th of November, which is the Physics of Breakfast by Peter Juncker. His talk was a little bit about the different phenomenon that we can observe related to breakfast foods and how they happen. The first topic was on the spilled coffee effect. Um, when someone spills their coffee, often you can see that when it dries, the outside it forms this thick ring. So how does this happen? A model was created to emulate the coffee spilling effect, and we found that surface tension as well as pinned drop edges are the cause of this. With surface tension, the molecules are trying to minimize their surface area, and the dropped edges are pinned during evaporation. So this causes the drop to have the fluid flow from the middle of the drop to the edges. And as this happens, a thick ring develops around the outside. And the next topic was related to cooking eggs or scrambling eggs. Really, when you put water into a hot pan, it'll evaporate. But when you put raw eggs into a hot pan, they form a solid. The question was, how does this happen? And a creep test was done using a universal testing machine, and this found that eggs are somewhat elastic. They're a protein suspension with hydrophilic and hydrophobic regions, and these regions act as a Velcro. And when you heat them up, you're denaturing the proteins, which is essentially the opposite of folding the Velcro. So this creates this network of these proteins and really forms the solid egg. So the final topic was the Cheerios effect. So this is commonly seen when you're down to the last few bites of your Cheerios, and the last few bites of Cheerios clump together. So why does this happen? Well, the main reason for this effect is that Cheerios bump into each other in order to decrease their potential energy. And by decreasing their potential energy and coming together, they actually rise up higher along the milk, which is the optimal energy state. The whole point of this, like I said, was that we can examine different physical phenomena all around us without even using microscopes or other complex physical equipment. So a related topic would be cracking an egg. So as many people may know, it's much easier to crack an egg when you crack it along the side than it is when you're cracking it on the tip of it. And scientists at MIT have been studying this and why this really is. So what they found that is when you're cracking it along the tip, it's harder because the angle that you're cracking the egg at is a sharper curve, and this causes the force that you need to crack the egg to need to be greater in order to crack it. They developed a computational model, and they're now able to determine the thickness of an egg or other ovoid shapes just by seeing the force needed to crack these eggs. So that's going to wrap it up for me, but thank you.